Hello, YouTube. How is everybody doing? It's Ben here, and I am doing this video for physics. Today, I will show you two physics problems so you can gain more knowledge and so I can make up points I missed. First problem will be height and time t. The second will be initial velocity. Enjoy. Problem 1. Height and time t. A soccer player kicks a soccer ball trying to score on their opponent. The player volleys the ball 1 meter from the ground and the opponent is 12 meters away. The opponent is 2 meters tall while the crossbar is 2.5 meters high. If the soccer player kicks the ball at 20 meters per second at an angle of 10, does he score the goal? The first step in this problem is to draw a picture. Alright, here's my picture. You can see that he is kicking the soccer ball, projected to be inside of the goal. It's not drawn to scale, please don't hate. And you can see I have all my variables. I have velocity, the angle, the height, the distance, and then the height of both the goalie and the crossbar. Step 2 is to list the variables of what we know. So we have listed here, we have the acceleration of gravity, negative 9.80 meters per second squared. We have our distance in the x direction, 12 meters. We have our angle, which is 10 degrees. We have our velocity, which is 20 meters per second. We have the height of our ball, which is 1 meter. Our keeper, which is 2, and the bar, which is 2.5 meters. And we will be using our angle and our velocity to find the initial velocity in the y direction and then the x direction, which we need to solve height in time t. Alright, we are ready to solve the problem now. We are going to find initial velocity in the y and x direction using our degrees and initial velocity. So, using trigonometry in the triangle, we can find out the initial velocity in the x and y direction. So the initial velocity in the y direction is 20 meters per second times sine 10 degrees equals 3.473 meters per second. Our velocity in the x direction equals 20 meters per second times cosine 10 degrees equals 19.70 meters per second. We are looking for the height and time t, so we need time. So the next thing to do is to solve for time. So we will use the equation distance equals rate times time, and we will change it so that time equals distance divided by rate. I just want to let you guys know you're doing great so far, and I'm very proud of you. Okay, now we are going to plug in numbers to our equation, which would be 12 meters, because that is our distance, and 19.70 meters per second, because that is our velocity in the x direction. Since we are doing this in the x direction, the distance and the velocity in the x direction, so you'll be using our bottom answer here when we started finding our velocity in the initial y and x. And our answer will be 0.6092 seconds, which I added that in my known variables, just so I am more aware. Alright, we now have every variable we need to solve this problem. Yay! It's now solve time. We're going to use the equation height equals initial height plus velocity, initial velocity in the y direction times time plus 1/2 of gt squared. And keep in mind, guys, if the height is between 2.0 meters and 2.5 meters, the player scores. So, will he score the goal? Alright, it is now time to plug in our known variables. So we have height equals 0 meters plus 3.473 meters per second times 0.6092 seconds plus 1/2 times negative 9.80 meters per second squared times 0.6092 seconds squared. Will he make the shot and score? No, the player missed. The answer was 0.297 meters, and it needed to be between 2.0 meters and 2.5 meters. Poor guy. You're going to stand in view right here. Okay. Oh. All right, great job, everybody. Now let's do problem 2. All right, let's go. Problem 2, initial velocity. Are you guys excited? Because I am. What initial velocity should a soccer player use to pass a soccer ball in the air at 60.0 degrees to a team member 40.0 meters away, 2.00 meters above the ground? All right, problem 2. We have drawn our picture now. This problem is different than the last one, that now we are solving for initial velocity. So we have our picture here. We have the degree when he hits the ball, 60.0 degrees. We know that the teammate is 40.0 meters away, and that the ball is to be given to him 2.00 meters in the air. Now we are solving for initial velocity. All right, now we have listed our variables. So we do not know the initial velocity, which is what we are solving for, but we do know that the angle is 60.0 degrees. The distance in the x direction is 40.0 meters. We know that the acceleration of gravity is negative 9.80 meters per second squared, and that the height that the ball is to go to the player is 2.00 meters. All right, guys, it is math time. We're going to use this magic equation to find our initial velocity. So, initial velocity equals distance divided by cosine of our angle times the square root of g divided by 2, then parenthesis, h minus, and then inner parenthesis, the tangent of our angle, then close the parenthesis, times distance, and then close it, and that will be our magic equation. Now we are going to plug in our known variables, and we will have 40.0 meters divided by cosine 60.0 degrees times the square root of negative 9.80 meters per second squared divided by 2 times 2.00 meters minus tangent of our angle 60.0 degrees times 40.0 meters. And our initial velocity is... Our answer is 21.6 meters per second. Wow. You guys did so good. Alright, thank you everybody for watching so much. It means so much to me. I hope you enjoyed the video. Hashtag GoPhysics, and have a wonderful day. Physics joke of the day. Where does bad light end up? In a prism. Ha! Bye everybody.